A colossal stone wall stands perfect, defying every tool its builders should have had. This is the lost science behind ancient megaliths and precision stone architecture, a forgotten knowledge that challenges our entire understanding of the past. By the end of this journey, you will see these ancient wonders not as primitive monuments, but as the work of a sophisticated and mysterious science. How did they cut granite with the accuracy of a modern machine? And why do the same impossible building techniques appear across separate continents? What does our own future hold if we could rediscover what they once knew? These stones are a silent rebellion against our historical timelines. The word megalith, born from ancient Greek terms for large and stone, feels almost too simple for what we are witnessing. It names the material but completely misses the message. We are not looking at random piles of rock. We are confronting a global architectural language written in geometry and gravity. Consider the immense trilithons of Stonehenge, their lintels perfectly locked onto towering uprights, or the sprawling complex of Pumapunku in Bolivia, where andesite blocks were cut with interlocking tabs and sockets that resemble modern industrial fabrication. These builders were not just strong, they were brilliant geometers and astronomers. They understood load distribution, seismic stability, and the precise paths of the sun and stars. The core mystery tightens around a single, haunting question. How could cultures separated by oceans and millennia arrive at such similar, advanced solutions, all while supposedly wielding nothing more than copper chisels and stone hammers? This is the gap that captures our imagination, the chasm between the tools we have found and the work they clearly accomplished. To find the first clues to their lost science, we must move beyond the grand scales and examine the smallest details, the microscopic evidence left on the stone itself. High in the Peruvian Andes, the fortress of Sacsayhuamán presents a puzzle cut from solid limestone. Its walls curve in a dramatic zigzag pattern, built from blocks so immense they seem like the work of giants. Each stone is a unique, irregular polygon, weighing as much as 100 tons, and they fit together with a precision that baffles the eye. The joints between them are not straight lines, they are complex, meandering seams. You cannot slide a single piece of paper into the gaps. This is not simple stacking. This is a three-dimensional stone jigsaw puzzle on a colossal scale. The technique is known as Polygonal masonry, and its genius lies in its defiance of simple force. Think of a wall built with uniform, rectangular blocks. A powerful earthquake can shake it apart along its straight, continuous lines, but a wall like Sacsayhuamán, with its interlocking, irregular shapes, has no straight lines of weakness. During a seismic event, the entire structure flexes and settles, the stones locking ever tighter, redistributing the immense forces through their intricate geometry. It is a design that has withstood centuries of tectonic activity, a silent testament to its builders' profound understanding of their environment. This leads us to the heart of the mystery, the how. To achieve this, each block had to be custom-shaped to fit its specific neighbors on all sides. There is no standard mold, no simple template. Every single one of these colossal stones is a one-of-a-kind piece, carved to interlock perfectly with the unique contours of the stones above, below, and beside it. The process of fitting them would have required constant trial and error, a slow, meticulous dance of positioning, marking, and recarving these 100-ton puzzles. The conventional explanation of stone hammers and copper chisels feels utterly inadequate against such a task. How do you achieve this level of soft clay-like precision on some of the hardest stone on Earth without leaving a single tool mark we can recognize today? The walls stand as a silent, defiant question, challenging us to rediscover a lost art of working with stone. Yet the mystery of polygonal masonry is only the beginning. To find an even deeper enigma, we must travel from the sun-drenched walls of Peru to the shadowy chambers deep inside the Great Pyramid of Giza. While the pyramid's exterior is a monumental feat, its most profound secrets are sealed within. The King's Chamber, a space meant for eternity, is constructed from massive blocks of red granite. This stone is far harder than the local limestone used for the pyramid's main body, presenting a monumental challenge for any builder. The surfaces of these granite slabs are not just smooth, they are flawlessly flat over their entire immense area. Their corners are not approximations, they are perfect right angles, cut with a precision that we would measure in fractions of a millimeter today. But the true shock lies in the room's centerpiece, the coffer. This massive box is carved from a single, solid block of the same unforgiving red granite. Its exterior is a marvel, but its interior is an impossibility. The inside corners of this coffer are so sharp, so perfectly crisp, that they defy our understanding of toolmaking. Even with our modern diamond-tipped cutting tools, achieving such a sharp internal corner in solid granite is a near insurmountable task, as the rotating tools we rely on naturally leave a slight, rounded curve. So how was this accomplished thousands of years ago with the supposed tools of copper and stone? This is not a question of brute force, but of a technology that appears to have vanished. The evidence carved into the granite itself points toward a method that treated the hard stone almost like a soft material, shaping it with an ease we can scarcely comprehend. This concept of stone softening is not merely a wild speculation, but a thread we must follow into the heart of the lost science itself. But this architectural puzzle extends far beyond the mountains of Peru. A nearly identical stone language appears in the most unexpected places across the ancient world. Deep within Egypt, the subterranean halls of the Osirian are built with the same colossal, interlocking blocks, defying the dry desert air with their seamless joins. High in the sacred valley, the terraces of Ollantaytambo echo this design, with stones so perfectly fitted they seem to have been poured into place rather than carved. And on the other side of the planet, in Japan, the mysterious Ishi no Hoden monument rises from a pond, its faceted, polygonal surfaces a mirror image of techniques used continents away. This is not a coincidence, it is a global signature. How could cultures separated by oceans with no known contact develop the same incredibly complex and labor-intensive building method? Two compelling possibilities emerge from the stone itself. The first is the idea of a shared, ancient knowledge, a foundational science of stone that was somehow known to separate civilizations, perhaps carried by early seafarers or stemming from a common, forgotten source. The second possibility is even more profound. What if these builders, working independently, all arrived at the same conclusion because they had discovered a fundamental truth about their material? They may have each realized that polygonal, interlocking masonry is simply the most stable, durable, and earthquake-resistant way to build with massive stone, a universal solution to a universal problem of permanence. The consistency is the key. From the Andes to the Nile to the islands of Japan, the core principles are identical. Mortar is absent, relying solely on perfect fits and gravity. The stones are polygonal, eliminating straight weakness lines. The structures are designed to settle and lock together over time, becoming stronger with each passing century and every tremor of the earth. This points less to a single teacher and more to a shared, deep understanding of geometry, physics, and the very land they built upon. These ancient engineers were not just copying a style, they were applying a supreme logic, a lost science of stability written directly into the bedrock of our world. And if this was their understanding of stone on a grand scale, what unimaginable methods did they use to shape it on the smallest, most precise level? The challenge of moving these stones is as immense as the blocks themselves. We can understand how a single 100-ton block might be fitted into a wall, but how do you transport a 1,200-ton obelisk across miles of desert? The answer begins in the quarries where the stones were born. At Aswan in Egypt, the unfinished obelisk remains partially attached to the bedrock, a project abandoned after a crack appeared. It is a fossilized moment in the construction process, revealing how these giants were first freed from the earth. Workers carved deep channels around the intended stone, then likely used wooden levers and water-soaked wedges to gradually prise it from its cradle of granite. This was a monumental effort, but it was only the beginning. The real miracle was movement. Once free, this 1,200-ton needle of stone needed to be moved from the quarry, loaded onto a barge on the Nile River, and transported to its final sacred site. The scale of this task is difficult to overstate. Even with our most powerful modern cranes and heavy transport vehicles, moving such a weight would be a complex and perilous operation. The same mystery repeats itself at Baalbek in Lebanon, where the stone of the pregnant woman waits in a nearby quarry. This limestone block is estimated to weigh over 1,000 tons, a true colossus that was somehow moved into position to form part of the temple's foundation. The conventional theory involves armies of laborers, massive wooden sleds, and tracks lubricated with water or clay to reduce friction. This method is plausible for smaller stones, but for weights exceeding 1,000 tons, the physics becomes a nightmare. The sleds themselves would likely splinter under the colossal pressure, and the force required to initiate movement would be almost unimaginable for human or animal power alone. This gap between plausible theory and practical reality has led researchers to consider more unconventional ideas. Some ancient texts and local traditions speak of a lost science of sound, a technology where specific frequencies or vibrations could cancel or drastically reduce the effects of gravity. The concept of acoustic levitation, where an object is suspended and moved by sound waves, seems like pure science fiction. Yet, if such a knowledge existed, it would elegantly solve the puzzle of how these stones were moved across great distances without leaving deep ruts in the landscape or destroying the transport systems themselves. Whether through a forgotten physics of sound or a supremely masterful application of simple machines that we have yet to fully comprehend, the transportation of these megaliths stands as one of history's greatest engineering enigmas, pushing us to look beyond our standard tools and consider a world where the very laws of nature were harnessed in ways we can only begin to guess. While the pyramids and polygonal walls demonstrate a mastery of earth and stone, other ancient builders looked to the sky. High on the Salisbury Plain in England, the Great Circle of Stonehenge stands as a silent testament to celestial observation. This is not merely a ring of stones, it is a sophisticated astronomical instrument built on a colossal scale. The most famous alignment is with the summer solstice sunrise, where the sun appears to rise directly over the distant heel stone, casting a long beam of light into the heart of the monument. But this solar event is just the beginning of its celestial story. The arrangement of stones also tracks the far more complex 18.6-year cycle of the Moon, marking its most extreme northern and southern rising points, events known as the major and minor lunar standstills. To encode these long-term cycles into architecture required generations of meticulous observation. It implies a civilization that watched the sky for centuries, carefully recording the slow dance of celestial bodies, and then possessing the technical skill to translate that data into a permanent, physical calendar made of 30-ton sarsen stone. The precision involved is staggering. Each upright stone had to be perfectly positioned and oriented, its top lintel carefully jointed and leveled to create a continuous circle in the horizontal plane. This was not a rough approximation, it was an exercise in exacting engineering applied to a cosmic blueprint. The builders of Stonehenge were not just astronomers, they were architects of time itself, using immense blocks of stone to pin the cycles of the sun and moon to the English landscape. Their science was a unified one where understanding the heavens was inseparable from mastering the earth, and their greatest monument stands as a permanent bridge between the two. The ruins of Pumapunku lie shattered across the Bolivian highlands, a landscape of architectural chaos that tells a story of immense, deliberate power. But to call these stones ruins is almost a misnomer. They are not worn down by time, they are exploded, as if some unimaginable force tore a perfected structure apart. And within that debris lies the true mystery. The individual stones themselves are not broken. Each piece, carved from incredibly hard andesite and granite, remains a masterpiece of precision. Their surfaces are flawlessly flat. Their edges meet in perfect 90-degree angles sharper than any modern steel blade could easily achieve. They are covered in a complex geometry of clean-cut channels, precise drilled holes, and intricate patterns that look less like chisel marks and more like the work of a computer-controlled milling machine. The most famous of these are the H-blocks, a series of identical stone components that look like giant, modular building bricks. Each H-block has a series of identical recesses cut into its face, pockets so uniform in depth and shape that they appear to have been stamped out by a single, massive punch. This is a concept we understand today as mass production, where every part is interchangeable. But at Pumapunku, this principle was applied to some of the hardest stone on Earth, with a precision that we would struggle to replicate without advanced digital guides. The conventional narrative of laborers grinding away with stone hammers and copper tools collapses here. How do you achieve such machine-like perfection across hundreds of separate blocks without a single visible tool mark, without a single error in measurement? The stones of Pumapunku do not suggest a slow, artisanal process. They point to a system of prefabrication, a grand architectural plan where every component was designed on a technical drawing long before it was ever cut, and then assembled into a whole we can now only try to imagine. This was not merely construction. It was a form of ancient engineering so advanced that its very existence forces us to reconsider the entire timeline of human technological development. What kind of civilization possessed the knowledge to work with stone as if it were soft clay, and what catastrophic event scattered their perfect puzzle across the high desert? Deep beneath the sands of Saqqara, a different kind of precision lies hidden in the dark. The Serapeum is not a temple for the living, but a silent city for the sacred. Its long, straight tunnels are lined with enormous boxes, each carved from a single, solid block of granite. These are not rough coffins, they are monolithic containers of breathtaking exactness, with walls as thick as a modern bank vault and a weight that can reach 100 tons. To stand beside one is to feel a profound dissonance, a clash between the ancient world we think we know and the impossible artifact before our eyes. The interior surfaces of these boxes are not merely smooth, they are polished to a mirror-like finish, a condition known as optical flatness. This means the surface is so perfectly even that it deviates by less than the wavelength of light. Running a hand along the inside corner, you would find it sharp and crisp, a perfect 90-degree angle maintained with machine-like consistency across every single box. The lid, a slab of granite just as massive as the box itself, fits into a precisely cut lip with a seam so tight it appears to be a single, continuous piece of stone. While their purpose as a final resting place for the Apis bull is part of the historical record, the method of their creation defies it. This is not handcraft in the way we understand it. The sheer repetition of such flawless work, box after identical box, points to something far beyond artisanal skill. It suggests a standardized manufacturing process, a repeatable technology that could reliably shape unforgiving granite into perfect, high-tolerance vessels, as if they were being produced on an assembly line thousands of years before the Industrial Revolution. The mystery of the Serapeum is not what these boxes were for, but how a civilization could achieve such peerless, repeatable perfection working in near-total darkness, with a material that would quickly destroy any copper tool we have ever found. The silent stones of the Serapeum hold another secret, one that resonates not with sight but with sound. Across the ancient world, these megalithic structures possess a hidden acoustic dimension, a science of vibration woven directly into their architecture. Deep beneath the island of Malta, the Halsaflieni hypogeum is a labyrinth carved from solid limestone. Within its underground chambers, something extraordinary happens. A deep male voice spoken in a specific room can be heard with perfect clarity throughout the entire three-level complex, while those standing right next to the speaker hear almost nothing. The chamber resonates, amplifying and distributing the sound in a way that defies simple explanation. It is believed to resonate at a frequency of 110 Hz, a specific vibration that some researchers suggest can alter brainwave patterns, potentially inducing states of heightened awareness or tranquility. This was almost certainly by design, an architectural manipulation of sound for ritual or healing purposes. The same principle echoes within the Grand Gallery of the Great Pyramid. This steeply ascending corridor, with its massive, overlapping blocks, acts as a giant sound resonator. Chants or specific tones produced at its base would be focused and amplified as they traveled upward, creating an immersive auditory experience for anyone in the king's chamber above. This points to a profound and unified knowledge. The ancient builders were not just masters of geometry and astronomy, they were also acoustic engineers. They understood how sound waves propagate through stone, how to shape chambers to create specific resonant frequencies, and how to use those vibrations to affect human consciousness. This mastery of acoustics may have even been part of their construction method. Could they have used specific, powerful frequencies to vibrate stone, making it less brittle, easier to work, or even altering its apparent weight? The theory of sonic levitation, once dismissed as pure myth, begins to seem less fantastical when we listen to the evidence still humming within the stones themselves. This was a lost science where sound was not just for ceremony, but possibly a tangible tool, a physical force harnessed to shape the very world. But what if the stones themselves are not what they seem? The Geopolymer Theory presents a radical possibility that the ancient builders were not just master carvers but master chemists. This idea suggests that many of the colossal blocks, especially the pristine limestone casing stones of the Great Pyramid, were not quarried in the traditional sense. Instead, they were cast. Imagine a process where the builders took readily available natural limestone, crushed it into a fine powder, and then mixed it with a special alkaline activator, a kind of ancient chemical recipe. This would create a thick, slurry-like cement that could be poured into wooden molds right on the construction site. Once it hardened, the result would be an artificial stone, a geopolymer, chemically identical to natural limestone but perfectly shaped. This single idea could elegantly solve several persistent mysteries. It would explain why there are no tool marks on the surfaces of many blocks, because they were never cut. It would explain how such massive stones could be fitted together with seams thinner than a human hair, because the material was poured and hardened in place, creating a near-perfect joint. It would even explain the incredible speed of construction proposed for some pyramids, as casting blocks on site would be dramatically faster than quarrying, shaping, and transporting them from miles away. The implications are staggering. This would not be simple concrete work. It would represent a form of ancient nanotechnology, a deep understanding of the chemical bonds that hold stone together. They would have been manipulating matter at a molecular level, creating a synthetic rock that was, in some ways, superior to the natural stone. If true, then we are not looking at quarried monuments at all. We are looking at the world's first and most advanced polymer science, a lost art of literally growing stone, a technology that would redefine our entire perception of the ancient world. The silent perfection of these structures rests upon a hidden foundation of absolute precision. Before a single stone was set, the ancient builders faced a challenge of almost unimaginable scale: the need to level the very earth itself. The entire Giza Plateau, the colossal foundation for the Great Pyramid, is flat to within a fraction of an inch across its vast area. This is not a rough approximation. It is a degree of accuracy that would be demanding even with our modern laser levels and satellite positioning systems. Without these tools, the task seems superhuman. How did they achieve such perfect horizontality, a requirement so critical for the stability and celestial alignment of their monuments? The answers may lie in elegantly simple yet brilliant applications of basic physics. One compelling theory involves the use of water. Imagine a network of shallow trenches carved directly into the bedrock, all interconnected and then filled with water. The surface of still water always finds a perfect horizontal plane, a universal constant the builders could harness. By measuring down from this waterline at countless points across the site, they could methodically chip away the high points of the plateau until the entire foundation met the same exacting standard. This was not a quick process, but a testament to meticulous, patient labor guided by a fundamental law of nature. Another possibility involves long sighting tubes, perhaps made from hollow reeds or crafted wood, filled with water to create a lens effect. These could be used to align markers over great distances, perhaps even using the consistent arc of specific stars as a celestial reference for true level. Then there is the power of simple geometry, the cord and peg method. By creating large, precise triangles on the ground with measured ropes, they could establish perfect right angles and check for level across a grid, a technique that relies on mathematical certainty rather than complex tools. This foundational skill reveals the core of their lost science. It was not magic, but a profound and practical understanding of mathematics, physics, and astronomy, all applied to solve a fundamental engineering problem. Their greatest architectural wonders did not rise from guesswork, but from a bedrock of measurement so exact it still defies our expectations. If they could tame the land itself with such peerless accuracy, what other secrets of measurement and proportion are still encoded in the stones above? This perfect geometry was not just for strength, it was a language. The stones themselves speak in a silent code of angles and ratios, a physical representation of a universe governed by mathematical order. The ancient builders inscribed their deepest cosmological beliefs not on fragile parchment, but directly into the enduring granite and limestone. Look at the Pyramid of Khafre at Giza. Its proportions are not arbitrary. The relationship between its base perimeter and its height echoes the mathematical constant pi, the ratio of a circle's circumference to its diameter. This is not a coincidence. It is a deliberate architectural choice, embedding a fundamental truth of mathematics into the very shape of the monument. Similarly, the harmonious proportions found throughout the design, from the spacing of internal chambers to the angle of its ascent, often align with the golden ratio, a number approximately equal to 1.618, revered for its appearance in natural forms from seashells to spiral galaxies. This was far more than advanced engineering. It was a form of sacred science where building a temple or a tomb was an act of cosmic mirroring. The structure became a microcosm of the ordered universe, a place where the principles of heaven were made visible on earth. The precision of their stonework, therefore, served a dual purpose. The seamless joints guaranteed physical permanence, while the encoded geometry guaranteed a spiritual and philosophical permanence, a permanent record of their understanding. This suggests that the lost science we are searching for was not a mere collection of construction tricks. It was a holistic discipline, a unified field of knowledge where the practical skill of moving a 100-ton block was inseparable from the mathematical genius of calculating pi, and both were expressions of a shared spiritual worldview. The stone was not just a building material, it was the tablet upon which they wrote their grand theory of everything. In their world, to build with perfect geometry was to participate in the divine order of creation itself, making each monument a bridge between the human and the cosmic. The physical evidence for this lost science is not just architectural, it is microscopic. Scattered throughout museum collections are artifacts that tell a story our history books have missed, bearing the unmistakable marks of a technology we do not attribute to their age. In the Petrie Museum in London rests a simple-looking cylinder of granite, a core sample drilled from a much larger block. To the untrained eye, it is unremarkable. But to an engineer, it is a revelation. The surface of this core is inscribed with a continuous, perfectly uniform spiral groove, a record of the cutting tool's path. The groove is deep and clean, and its consistent spacing indicates a feed rate, the speed at which the drill bit was pushed into the stone, that is both rapid and unwavering. This is not the hesitant, irregular mark left by a hand-powered copper drill loaded with sand abrasive. Such a method would produce a slow, jerky progress and would quickly wear down the soft copper tube, leaving a much rougher and more variable surface. This granite core suggests a tool that was fed into the stone with immense, steady pressure and cutting power, the kind of power only achievable with a fixed, mechanical apparatus. The implications are staggering. It points to a drill that was not only harder than granite, but was also mounted in a machine capable of delivering a consistent, powerful thrust, a technology that simply does not fit into our conventional timeline. The same story is written in the saw cuts found on granite boxes and statues. The marks are long, straight, and perfectly parallel, indicating a blade that moved back and forth in a rapid, mechanical motion. A man wielding a hand saw, even one embedded with abrasive material, would inevitably create wavering, uneven strokes. The evidence we see, however, speaks of a process that was smooth, relentless, and machine-driven. This is not a matter of lost artistry, but of lost engineering. These grooves and cuts are the fossilized signatures of powered machinery, the ghost in the machine of the ancient world. They imply a level of industrial capability that has vanished without a trace, leaving behind only these silent, stubborn scratches on stone, challenging us to explain how they were made with the tools we admit they had. The silent stones hold a deeper secret, written not in their cuts but in their scars. Across the sun-baked plains of Giza, the Great Sphinx stands guard, its limestone body deeply furrowed by vertical channels and undulating hollows. To a geologist's eye, this is not the work of wind and sand. Sandblasting erosion creates horizontal, sharp-edged features. The patterns on the Sphinx are classic, textbook examples of precipitation-induced weathering, the kind caused by thousands of years of heavy, relentless rain. This presents a profound chronological problem. The climate of Egypt has been predominantly arid for the last 5,000 years, yet the water weathering on the Sphinx suggests it was exposed to a very different environment, one that existed over 12,000 years ago. If this is true, the origins of this iconic monument may be pushed back into a forgotten epoch of human history, a time mainstream timelines consider prehistoric. The same story is etched into the dark basalt blocks of the Osirian at Abydos. These massive stones are not just worn, they are rounded and softened to an extreme degree, as if smoothed by the slow, patient hand of flowing water for millennia. This level of degradation points to an immense, almost unimaginable age, far exceeding the standard historical assignment. What if our dating of these sites is fundamentally incorrect? The implications ripple out, challenging the very foundation of our historical narrative. If these structures are not the products of the dynastic Egyptians we know, but of a far older precursor culture, then an entire chapter of human achievement has been erased from our collective memory. This would mean that advanced knowledge of astronomy, engineering, and stonework was not invented in the cradle of civilization as we define it, but was instead rediscovered, a legacy inherited from a lost world. The weathering on the stone is more than just erosion. It is a clock we are only now learning to read, and its hands point to a timeline that demands we reconsider everything we thought we knew about our own past. Why would a civilization pour generations of effort into surfaces no one would ever see? Deep beneath the visible grandeur of a temple, its foundations are often the most perfectly crafted elements, with joints tighter than those in the walls above. This obsessive precision transcends practical stability. It points to a motive woven into the very philosophy of their science. For these builders, the act of creation may have been a ritual in itself. Each flawless seam, each optically flat surface could have been an offering, a deliberate act of imposing perfect, divine order onto the chaotic nature of raw stone. In this worldview, a perfectly joined block was not just a building component, it was a resonant object, a node in a larger energetic circuit designed to harmonize with the earth itself. Perhaps they believed that such geometric purity allowed the structure to channel subtle natural forces, becoming a kind of spiritual battery or a stable anchor between the earthly and the cosmic. The immense effort was not wasted because it was unseen. It was essential because it was foundational to the entire purpose of the monument. Alternatively, this invisible perfection served as the ultimate demonstration of power. A ruler or priesthood that could command such impossible craftsmanship was not just wealthy, they were in possession of a knowledge that bordered on the supernatural. It was a permanent, unassailable statement carved in stone for future generations to find. We built this not just with armies, but with an understanding of reality that you have since forgotten. The why behind this precision is the final piece of the puzzle. To understand their lost science, we must accept that for them, there was no separation between the spiritual and the physical, between a prayer and a perfectly cut stone. The work was the worship, and the precision was the proof of their connection to something far greater than themselves. This absence of physical tools is the silent scream in the archaeological record. If these builders possessed diamond-tipped saws or sonic cutters, where is the evidence? Where are the worn-out blades, the broken drill bits, the machine parts? The conventional answer is that they used simple copper and stone tools, but as we have seen, that explanation crumbles against the evidence left on the granite itself. So the mystery of the missing tools becomes as compelling as the structures they created. One possibility is that the tools were not just tools, they were treasures. Imagine a master craftsman possessing a set of cutting instruments made from an advanced alloy or embedded with rare crystals. These would not be discarded carelessly at a job site. They would be guarded, protected, and ultimately, when the culture that created them faded, they may have been carefully hidden away or melted down for their valuable materials, their original purpose forgotten. Another explanation points to tools made from organic components. What if the cutting power came not from a hard blade, but from a specially formulated plant-based paste, a chemical agent that could temporarily soften the molecular bonds of the stone, allowing it to be shaped almost like wet clay? Such a substance, once used up, would leave no permanent trace beyond the impossibly smooth stone it helped to create, or consider the possibility of sound. The greatest tool may have been a specific, powerful frequency generated by large wooden or stone resonators. This acoustic technology would leave behind no physical cutting implement to find, only the shaped stone and perhaps vague traditions of a time when the rocks themselves could be sung into place. This leads to the most profound possibility of all. Perhaps the ultimate tool was not a physical object at all, but a piece of knowledge, a precise recipe for a geopolymer mixture, a forgotten sequence of resonant tones, or a deep understanding of a stone's natural fracture points that could be exploited with minimal force. This was a tool that existed only in the minds of the masters and the training of their apprentices. When that chain of knowledge was broken, whether by social collapse, natural disaster, or the slow passage of time, the tool itself vanished without a trace. It was a technology built on information, not infrastructure, and once lost, it became a secret the stones themselves would keep forever. The legends whisper of stones that moved to the song of their masters, a concept that dances on the edge of myth and forgotten physics. Across cultures, from the high Andes to the deserts of the Middle East, stories persist of sonic levitation, where specific chants or the vibrations from drums and horns could lighten massive blocks, making them glide into place. While this sounds like pure fantasy, a practical thread connects these tales to the stones themselves. We know that water mixed with an abrasive sand slurry is a simple and effective way to cut through hard rock through patient, grinding friction. But what if this basic process was supercharged? Modern materials science reveals that high-frequency sound can induce something called acoustic softening, making certain brittle materials more susceptible to deformation. Imagine an ancient workshop where the constant, resonant hum of a tuned stone plate, vibrating at a precise frequency, subtly loosened the molecular bonds within a granite block. When the abrasive slurry was then applied, the cutting action could have become dramatically more efficient, turning a task of months into one of weeks. This union of water and sound transforms from a fringe theory into a plausible, sophisticated technology. Look at the evidence left behind. Many megalithic sites are intricately linked with water channels, cisterns, and subterranean chambers. At the Osirian in Egypt, the entire structure is submerged in water, which most archaeologists interpret as a ceremonial feature. But what if its purpose was also profoundly functional? A water-filled chamber could act as a powerful acoustic resonator, amplifying specific frequencies throughout the foundation of a building. The precise, machine-like saw marks and drill cores we find on granite could be the direct result of this hybrid technique, a process where the stone was made temporarily more malleable through resonant vibration, then shaped with a water-driven abrasive process that left those impossibly clean, rapid cut marks. This suggests the ancient builders saw water and sound not as separate elements, but as partners in a unified physical science. They may have understood that everything has a resonant frequency, a natural vibration, and by harnessing that principle, they could interact with solid stone in a way that appears to us as magic, but to them was simply the next logical step in a masterful understanding of their world. But the precision of these ancient builders extends far beyond the single stone or even the single building. The entire sacred landscape was a single, unified equation. The ground plans of many megalithic sites are not random placements. They are complex, sprawling mathematical puzzles written directly onto the earth. The most famous of these cosmic blueprints is the Giza Plateau. The three great pyramids are not arranged in a simple straight line. Their layout is said to be a terrestrial mirror of the three stars in Orion's belt. The angles between the pyramids, the specific distances separating them, and their relative sizes all correspond with uncanny accuracy to the celestial pattern above. This is not a vague similarity. It is a precise, scaled-down map of the heavens, frozen in limestone and granite. To achieve this, the builders needed more than just observation. They required a standardized unit of measurement and a sophisticated system of geometry that seamlessly integrated terrestrial distances with celestial maps. They possessed a science of correlation, a profound understanding that the principles governing the stars were the same principles that should govern their sacred architecture on Earth. The pyramids were not just tombs pointing at the stars. They were active participants in a cosmic order, physical anchors for a celestial blueprint. This same principle of encoded mathematics appears across the globe. The massive geometric shapes of the Nazca lines in Peru can only be comprehended from high above. suggesting a knowledge of surveying and large-scale planar geometry that seems out of place in its time. The complex of Teotihuacan in Mexico is laid out on a grid that incorporates specific astronomical alignments and mathematical constants like pi into the angles of its streets and the dimensions of its pyramids. This recurring theme points to a universal language, not of words, but of numbers and ratios. The megaliths were the permanent nodes in this vast, invisible network, a physical manifestation of the belief that to build in harmony with the cosmos was to tap into the very source of order and power. The stones were placed not just for strength, but to complete a sentence in a conversation between the earth and the sky, a dialogue written in the silent, eternal language of mathematics. A single man, working alone under the cover of night, moved over 1,000 tons of coral rock. The story of Edward Leedskalnin and his coral castle in Florida is a 20th century whisper of the same ancient mysteries. From the 1920s to the 40s, this slight, 5-foot-tall Latvian immigrant single-handedly quarried, carved, and erected massive blocks of oolitic limestone, some weighing as much as 30 tons. He built a complex complete with a 9-ton gate that a child could push open with a single finger, a perfectly accurate sundial, and a Polaris telescope, all carved from stone. When asked how he managed such feats alone, he would only offer a cryptic smile and say he understood the laws of weight and leverage used by the builders of the pyramids. He claimed to have rediscovered the secret that allowed the ancients to move their colossal stones. His methods remain a complete enigma. He worked largely in secret, often at night, and threatened to topple his blocks if anyone tried to spy on him. Witnesses reported seeing him simply place his hands on the stones, sometimes with an old crate containing a mysterious device covered in wires, and hear him singing. The blocks, they said, seemed to float into place. The conventional explanations of block and tackle, tripods, and winches seem as inadequate for his work as they do for the stones at Baalbek. How could one man, with no visible heavy machinery, no financial backing, and no team of workers, accomplish what would normally require a small army and a fleet of cranes? Leedskalnin left behind not a single blueprint or tool, only his magnificent, bewildering castle and a few pamphlets filled with his musings on magnetism and the secrets of the universe. He spoke of understanding the relationship between the North and South poles, of a flow of individual magnets that could be harnessed to counter gravity itself. His personal library was filled with texts on magnetism and electrical currents, hinting at the direction of his research. The coral castle stands as a powerful, modern testament to the possibility that the lost science was not magic, but a profound and practical application of natural laws we are still struggling to grasp. It suggests that the principles behind these miracles of construction are not buried with a lost civilization, but are fundamental truths about our world, waiting in plain sight for someone with the insight to see them. If one man in the last century could rediscover this, what does that say about the potential still locked within our own understanding of physics? These eerily similar stone signatures across the globe form a compelling pattern, one that begs for a deeper explanation than simple coincidence. Why do we find the same fingerprint of impossible precision stamped onto monuments from the high Andes to the Egyptian desert, structures built by cultures supposedly unaware of each other's existence? One controversial but persistent theory suggests these are not independent inventions at all, but the scattered pages of a single, much older book. This idea proposes a predecessor civilization, a highly advanced global culture that flourished in a forgotten age, only to be erased by a planet-altering cataclysm. The Great Flood myths found in hundreds of separate cultures, from the Epic of Gilgamesh to the story of Noah, are interpreted not as mere legends, but as faint, distorted memories of this real historical event. In this view, the survivors of this shattered world, scattered to the winds, carried with them fragments of a once great knowledge. They became the teachers, the wise ones who seeded the nascent cultures of our known history with the principles of advanced astronomy, mathematics, and stonework. This would elegantly explain the sudden appearance of these sophisticated techniques in the archaeological record, seemingly without any long period of technological development. It was not an invention but an inheritance, over generations, as this knowledge was passed down through oral tradition and applied with diminishing resources, it slowly degraded. The perfect, seamless joins of the first temples gave way to the rougher, mortar-bound masonry of later dynasties. The profound understanding of the stars became ritualized and simplified. The lost science we are searching for, then, was not lost because people forgot how to do it, but because the original, unified civilization that perfected it was itself lost. This theory reframes these ancient wonders not as the proud achievements of the cultures we attribute them to, but as their most sacred heirlooms, the last echoes of a golden age whose name, like Atlantis, has faded into myth. While mainstream archaeology remains skeptical, the architectural evidence itself keeps this possibility alive, a ghost in the stone that challenges us to consider a timeline far deeper and more mysterious than we have ever allowed. Modern teams of archaeologists and engineers have dedicated years to solving these puzzles with their own hands. They gather hundreds of volunteers, heave on ropes, and painstakingly drag multi-ton stones on wooden sleds across lubricated tracks. They grind away at granite for days on end using copper saws and quarts of abrasive sand. In one famous project, a crew successfully erected a full-sized trilithon, proving that with enough people and perseverance, the basic mechanics of moving and lifting are conceivable. Yet these hard-won victories only highlight a more profound failure. While they can move a stone, they cannot move it with the speed implied by the construction timelines of the Great Pyramids. They can shape a block, but they cannot reproduce the optical flatness of the Serapeum boxes or the machine-tooled edges of Pumapunku. The process is always too slow, too imprecise, and far too destructive to the primitive tools they are using. The copper saws wear down to nothing long before the granite is cut, and the resulting surfaces are rough and uneven, a far cry from the mirror finishes we find on the ancient artifacts. This gap is not a matter of effort but of knowledge. The experiments demonstrate the upper limit of what is possible with the tools we have attributed to the ancients, and that limit falls dramatically short of what was actually achieved. The successful replica is a crude approximation standing next to a perfected original. It proves that we are still missing the core ingredient, the fundamental principle or technology that transformed an impossibly difficult task into a manageable one. These modern attempts are not failures, they are the most important clues we have. They tell us definitively that the lost science was not about brute force. It was about working smarter, not harder, using a method that has left no obvious trace in the archaeological record, a method that made stone behave in a way we can no longer replicate. Before a single stone could be carved or moved, the ancient builders faced a challenge that required a deep intimacy with the earth itself. They needed to find the perfect stone, and their geological knowledge was as precise as their architecture. These were not random piles of rock, they were carefully curated materials, each selected for its unique properties. For the immense, enduring statues of Egypt, they sought the unyielding hardness of Aswan granite. For the intricate carvings at sites like Copan, they chose a specific, fine-grained limestone that would hold sharp detail for centuries. The volcanic basalt used in Mesoamerican centers was prized for its toughness and dark, imposing presence. This was an applied science of materials, a profound understanding that the longevity and function of a monument began with the very bedrock it came from. Locating these perfect deposits was the first great feat. They likely observed natural outcrops, studied the flow of water over stone to gauge its hardness, and perhaps even tested samples with simple yet effective methods, striking stones together to listen for the clear ring that indicated a solid, uncracked internal structure. The quarries they established are masterpieces of efficiency in their own right. At the Olmec Head quarries of La Venta, the massive basalt blocks were extracted from a volcanic flow, with the ancient workers skillfully following natural columnar joints to minimize the labor of freeing each colossal head. At Aswan, the quarries are a landscape of organized extraction, with trenches and channels cut in ways that seem to peel the granite from the earth with minimal waste. The logistics were staggering, a form of ancient industrial project management. They had to coordinate teams of laborers, craftsmen, and overseers, managing the workflow from identifying the prime vein of stone to undercutting and freeing the block to preparing it for its journey. This entire operation, from geological survey to the first rough cut, reveals a civilization that did not fight against the earth, but worked in concert with it, reading the land like a map and harvesting its strongest bones to build for eternity. This social machine required a profound understanding of the human body. To sustain thousands of workers, the ancient project managers had to master the science of nutrition on an industrial scale. Excavations near the Giza Plateau have uncovered the remains of a vast bakery capable of producing thousands of loaves of bread daily, alongside evidence of large-scale fish processing and cattle butchery. This was not subsistence living. It was a carefully calibrated system designed to deliver the immense caloric intake needed for backbreaking labor. They were not just feeding people, they were fueling a human engine. This logistical feat extended to medicine as well. A workforce of that size living in close quarters would have been vulnerable to injury and illness. Evidence from worker settlements indicates the presence of skilled healers who set broken bones with remarkable success and used honey and herbs as natural antiseptics to prevent infection. This was an early, highly effective form of occupational health care, a system designed to minimize downtime and maintain the steady rhythm of construction. The entire operation, from quarry to foundation, was a symphony of synchronized labor. Teams of specialists worked in concert, not in chaos. Quarrymen freed the blocks, haulers transported them, and master builders positioned them, all guided by a central architectural plan that every level of the workforce understood. This level of coordination implies a communication network as robust as the stones they moved, a system of foremen, scribes, and messengers who kept the project flowing without the benefit of radios or digital schedules. The true marvel, then, is not just the pyramid that rose from the desert, but the invisible city that thrived at its base, a temporary metropolis built on the principles of care, coordination, and a shared monumental purpose. The true power of this lost science may have been its interconnected nature. It was not a collection of separate skills, but a single, unified body of knowledge where astronomy informed architecture, and chemistry served geometry. A master stonemason did not simply follow a drawing. He understood the celestial reason for a wall's specific angle. The mathematician who calculated pi for a pyramid's slope likely worked hand in hand with the geologist who selected the perfect limestone for that exact purpose. This was a holistic system, a seamless fusion of disciplines that we, in our modern world of specialization, have largely separated. The architectural genius of a seamless joint was inseparable from the astronomical alignment of the entire structure, and both were grounded in a profound understanding of the land's own materials and energies. To lose one thread was to unravel the entire tapestry. Imagine a master builder who held the chemical formula for a geopolymer cement, the astronomical data for celestial alignments, and the geometric principles for seismic stability all in his mind. If that individual or that small group of initiates passed from the scene without transferring the complete system, the knowledge would not just degrade, it would shatter. The chemical recipe without the architectural context becomes a curiosity. The star charts without the engineering principles are just stories. The collapse of this integrated knowledge explains why such a profound capability could vanish so completely from human history. It was not a single tool that was lost, but the entire operating system. The Romans, masters of their own empire, looked upon these older, colossal stones with a sense of awe that bordered on reverence. When they encountered the massive polygonal walls in places like Sacsayhuamán or the foundations of Baalbek, they could not reconcile the work with any human hands they knew. They called these constructions Cyclopean masonry, believing only the mythical race of one-eyed giants, the Cyclopes, could have lifted such impossible weights. This was not an insult to their own engineering prowess, but the highest form of compliment. They saw in these stones a standard they could not meet, a level of perfection that transcended their own understanding, and so they attributed it to the divine. This pattern of mythologization repeated itself across the world. The immense stones of Ollantaytambo were said to have been moved by the Incan gods themselves. The great blocks of Stonehenge were woven into the legend of Merlin, magically transporting them from Ireland. In every case, the real, tangible science behind the construction was so advanced that it became indistinguishable from magic to later generations. The knowledge did not disappear in a single moment. It likely devolved over centuries. A master stonemason might pass on only the basic principles of fitting stones to his son, who in turn would only remember the ritual chants that once accompanied the work, losing the underlying acoustic science. The precise chemical recipe for a geopolymer slurry might become a sacred, secret incantation, its practical ingredients forgotten. The hard, technical data of astronomy and geometry softened into the stories of gods and heroes written in the stars. This process obscures the historical truth, wrapping a sophisticated technology in the gauze of legend. Yet it also preserves something vital. The very fact that these stories persisted for thousands of years across countless generations tells us that the monuments themselves made an unforgettable impression. They stood as a permanent, silent challenge to every culture that came after, a reminder that the human relationship with stone once reached a peak we have yet to reclaim. Their legacy is not just in the stones they left behind, but in the persistent, haunting question they planted in our collective memory. What does it mean that our distant ancestors may have possessed a form of knowledge so potent that we, with all our digital tools and industrial might, still gaze upon their work and wonder how it was done? The polished surfaces of ancient granite are now speaking a new language, one of pure data. Modern science has begun to interrogate these stones with tools their builders could never have conceived, yet the answers they provide are forcing us to reconsider everything. High-resolution 3D laser scanners now map every contour and scratch on a stone block, creating a digital twin so precise it can reveal tool marks invisible to the human eye. Ground-penetrating radar sends pulses of energy deep into the earth, unveiling the ghostly outlines of hidden chambers and buried foundations without turning a single shovelful of dirt. These are not tools of speculation, they are instruments of revelation. A core sample drilled from a temple wall is no longer just a cylinder of rock, it is a historical document. Material scientists can analyze its microscopic structure, searching for anomalies in its crystalline formation or traces of foreign chemicals that might hint at a forgotten manufacturing process. The very chemistry of the stone is now part of the evidence. These technologies are systematically stripping away centuries of assumption. A scan might reveal a consistent, repeating pattern in the cutting marks on a granite box, a signature that points toward a specific type of mechanical motion. Radar might detect a void behind a wall, suggesting the structure was far more than a simple tomb. Each new dataset is a potential key, capable of unlocking a door we did not even know was there. This is not about proving one theory over another. It is about letting the stones themselves, through the language of empirical data, finally tell their own story. The lost science is no longer a subject for legends alone. It is becoming a field of hard evidence, where every pixel in a scan and every element in a spectrographic analysis brings us one step closer to the minds of the master builders. We are no longer just looking at their work, we are beginning to measure it, and in that measurement we are starting to hear their whispers. The sheer perfection of these stones shatters our most cherished assumptions about history itself. If a civilization without microchips or steel could achieve such feats, what does that truly say about the nature of progress and knowledge? We are taught a story of linear advancement, a steady climb from primitive tools to complex machines, a journey from ignorance to enlightenment. Yet these monuments stand as permanent counter-arguments to that simple narrative. They present us with an uncomfortable but thrilling possibility that science is not a one-way street. Entire libraries of understanding can be misplaced. Whole branches of a technological tree can fall silent, leaving only their fruit behind for us to puzzle over. This suggests that a society can possess profound, even supreme, mastery in one field, like resonant acoustics or molecular chemistry, while being completely unaware of another, like electricity or powered flight. Their path of discovery was not ours, and their results were equally, if not more, astounding. This realization forces a deep humility upon our own age of innovation. We celebrate our silicon chips and global networks, and rightly so, but we must also ask, what profound simplicities have we overlooked in our rush toward complexity? What fundamental relationships with natural forces, with sound, with stone, with the earth itself, did they understand that we have not yet even thought to study? The legacy of these builders is not just in the stones they left, but in the profound philosophical challenge they present. They ask us to be open, to consider that human potential is far vaster and more varied than any single timeline can contain, and that the future of discovery may well lie in recovering fragments of a forgotten past. Our journey through the lost science of the ancients reveals a world where stone was not a barrier but a canvas. It was a medium for expressing a unified and breathtakingly sophisticated understanding of the cosmos. From the earthquake-defying joins of Sacsayhuamán to the celestial clockwork of Stonehenge, the evidence carves a single, inescapable conclusion. This was not merely construction, it was a sacred science where physics, astronomy, mathematics, and spirituality were woven into a seamless whole. The builders saw no separation between the angle of a stone and the path of a star, between the resonant frequency of a chamber and the state of human consciousness. Their work represents a holistic vision of reality, one where every element of the physical world was interconnected and alive with meaning. We may never fully recover every secret of their methods, whether it was a forgotten chemistry for softening rock, a mastery of acoustic levitation, or a geometric language we are only beginning to decode. Yet the quest itself transforms our appreciation for human ingenuity. It pushes us to look beyond our linear timelines and consider the vast, uncharted potential of the human mind. These silent, enduring stones are our ultimate teachers, standing as permanent challenges to look deeper at our own history and to think broader about the very nature of knowledge and progress. They remind us that the greatest mysteries are not always hidden in distant lands, but are often buried in plain sight, waiting for a curious mind to ask the right question. If this exploration has sparked your own curiosity, we would love to hear your thoughts and theories in the comments below. Subscribe to continue this journey with us as we keep unraveling the greatest enigmas of our past.